Hey guys, today we're going to move on to talk about rational exponents. This should be one of the last things on your formula chart that has the exponent rules on it. So rational, if you think back to like the real number system last year, you had, remember this little chart? It looks like this. And it was the real number system here. Rational is right here. And rational means fractional. It means that any number that can be turned into a fraction is rational. If it can't be turned into a fraction, then it is irrational. So rational means that it is a fraction, but again, we're talking about exponents, so it's a fraction exponent. So if I have 3 to the power of 2/3, that's a rational exponent. If I have x to the power of 1/8, that's a rational exponent. Okay, so rational exponent is written in the form of a fraction where a is the base and m divided by n is the exponent. So this is saying we've got a base of a and it's to the power of n, m divided by n. So if we look here, using the calculator to evaluate the expressions, we can plug this whole thing right into the calculator and figure out what it is. We did that the other day with, I think it was 25 to the power of a half. So this one I'm just going to plug in exactly what I see, 32 to the power of 2 divided by 5, which is 4. So this one is 4. This one I've got 343 to the power of 2/3. So 343 to the power of 2 divided by 3. And I get 49. Lastly, again, just plugging in my calculator exactly the way I see it, I have negative 729 to the power of 5 divided by 6. I get negative 243. So again, you can just plug these into your calculator and see what you get. Okay, so now moving on, using the exponent rules, name to simplify the following problems. So this just means power to power, the multiplication exponents, the dividing exponents, you're just using those rules. So if we look here, we're multiplying. So my base here would be the x, and here's the exponent. So I know if I multiply, first I'm going to multiply numbers, there are no numbers, and I add the exponents. So I keep the base, and I've got negative 3 over 2 times 7 over 2. Okay? Multiplying the exponents straight across. Now, you can plug this straight into decimals too. We can do negative 3 divided by 2 times, times 7 divided by 2. Which gives me negative 21 over, y'all, I just told y'all we're adding, and literally, I put a multiplication sign. Jeez Louise. Okay, sorry. We're adding. So when I add, I just go straight across, and since they have a common denominator, oh my gosh. Since they have a common denominator, I just say negative 3 plus 7 is 2. Why am I multiplying? So I'm left with x equals 2. So same thing, just have fractions involved, nothing crazy. Again, here we're multiplying, so I'm going to keep my base, which is the x. And I'm going to multiply a half times a half. Not multiply, I'm adding. Y'all, gotta watch me. 1/2 plus 1/2. So remember when we multiply, add the exponents. So I've got x equals not x equals, x to the power of 1, which is really just x. And again, for multiplying, our rule was multiply. You multiply numbers and add exponents. So as a rule, remember to add. For some reason I'm multiplying. Okay, then I'm moving on down here. We were dividing. So this time for dividing, remember, we're going to divide numbers, so any coefficients, and then you subtract exponents. Again, this is just review, but we've got some rational exponents there. Okay, so 12 divided by 4 gives me 3. Then I have a base of d, and then I'm going to do 1/2 minus 3/4. These do not have common denominators, so you'd have to find a common denominator, or again, you can plug it into Desmos and say 1/2 minus 3/4, and it is negative 5/4. Okay, now, we would be done except we've got a negative exponent. We can never have a negative exponent. So I'm going to put this on bottom to make him happy, make me happy, make everybody happy. I have 3/d to the 5/4 power. Okay, this one. No numbers, so I'm starting with just the y as my base. And then I have 3 minus 8/3. So 3 minus 8 divided by 3 is 1/3. Positive, so I am done. Sorry, y'all, did I show you a screen on this one? I don't know if I did. So I did 12 divided by 4 is 3, then I had the d, and I had 1/2 minus 3/4, which is negative 5/4, and I had to move this whole thing down below to make him happy. I think I didn't have the right screen on, sorry. And then this one here, there was no numbers, so I just had the base of y, and I did 3 minus 8/3, and I got 1/3, which I plugged in Desmos. Okay, sorry. This one is the, sorry, do red. Yes, okay, so let's do blue. We've got power to power, which is just multiply exponents is the rule. So I'm going to take this 3 and its distributive property and multiplying it to everything inside. Keep your bases. So I've got a base of c, but I'm doing 3 times 5, which gives me 15. Keep the base of d, but I've got 3 times 1/2, which is 3/2. They're all positive, so that is my answer. I'm going to stay there. Okay, so there's a little review. Okay, rational exponents to roots. I think this is probably one of the easiest ones we've done all day. It looks like one of the most complicated, but it's actually not bad once you know the rule. So here's the rule. It's given to you on your formula chart. If I have a to the m divided by n power, I'm going to take the square root of a to the m power, but I'm not taking in square roots. You can put different numbers out here, which mean different things. You could take cube roots. You could take roots to the 4th. You can change whatever numbers out here. When you take a square root, it's a 2 there, but it's implied. So this little saying is going to help us understand how to go from rational exponents to get these roots. So what this stands for, TBO, stands for top, inside, bottom, outside. Okay, TBO is going to help us out here. So if you look here, first off, you need to know your base, which is pretty easy. That's the big number or letter, which is y. Now, top, inside. So the top number of my fraction is the inside exponent. Well, y doesn't have an exponent. It doesn't have an exponent, it's 1. So the top is inside. So my top number of my fraction is 1. The bottom of my exponent is outside, which is right here, which is 3. So this is really y to the 1/3 power. Okay, this guy. If there's no root, it's automatically a 2. We just kind of talked about that. The main root is a square root. You're taking what times itself gives me that number inside of the square root. So if there's nothing here, it's automatically 2. TBO, I'm going to take the A, that's my big one. Whatever's inside's on top, so 3's on top, and 2's outside, so it's on bottom. Top in, bottom out. Okay, this one. What you're going to do first is do the rational theorem. Forget about the 3. Pretend the 3's not there. So we're just going to do it here. X is to the power of 1, so I've got X top inside, so the top number is the 1, and the bottom's outside, so it's 1/4. Now that I have this, I'm taking this whole thing and I'm doing it to the power of 3. So now I'm taking this exponent, and I've got X 1/4 times 3 is 3/4. Okay. Now it wants us to rewrite the expression in rational exponent form. So I'm going from, oh, that's what we were doing. We're just practicing. Sorry. Okay, so I want you to practice number 12. Put me on pause and then we'll go over it. Okay, so my base is B. There's no exponent, so I know it's a 1 on the inside, but there's no exponent outside either. If it's no exponent outside, then it is 2. So it's 1/2. Okay, this one, again, my base is Z. Whatever exponent's inside goes on top. There's a 1, there's nothing there, and then the 5 is outside, so that's on bottom. Okay, base of X, 2 is inside, so it's on top. 3 is outside, so it's on bottom. So if you know the rule, you're just rewriting. There's no math involved, just rewriting stuff. So if we practice like on number 15, we'll have to do like what we did up here. We'll have to write it in the rational exponent theorem, and then do the power of power, distribute it, whatever we need to do to simplify it even further. So I'm going to forget about the 3. I'm going to write this as X, 1 on top because there's nothing there, and then 5 on bottom. All of this is to the 3rd power, so now I take the 3 and multiply it times 1/5. So I've got X to the 3/5 power. Okay, same thing here. I can't do it all at once. I got to do the rational theorem first. So I've got X is my base, 1, because there's nothing in there, there's 1X, and then 4 is on the outside. All of this is to the 2nd power. Take this 2, multiply it times 1/4. So I've got X to the 2/4, which 2/4 actually simplifies to 1/2. Okay, oops. Okay, so now what if I go the opposite direction? Okay, this part's easy. I'm always going to have the root. X goes inside because that's my base. Now remember, TBO. Top in, so here's my top number. Let me get a different color. My top number is 3, so that's inside. Bottom is outside, so that's my 4. So there's my answer. Okay, this guy, again, always going to have the root, my base, top is in, so 5 is in, bottom is out, so 2 is out. Now remember, if it's a 2, it normally does not have the little 2 outside there. It's just a square root. That's the main root we know. So that is not necessary to put. So this would be a fine answer. If you see it on a test, though, you're going to see it like this. They're both the same thing. This is most correct, though. So if you got answer choices or something, that's what it's asking for. Okay, again, I'm going to have my square root, or my root, G, top in, so 4 goes in, and then bottom number 9 is out. And ta-da! Y'all, that's it. That's all there is to it. So just changing from rational exponents to roots, that's all there is. Okay, bye y'all.